Alright, so we're going to do the Radii Turners. Just giving you a little look at the lathe that we're using, 1640 sharp. Here's the Radii Turner, and I slowed this down just to give you guys a good view of it. So you got everything to the right there are for turning different sizes and styles of radius. You know, they go together just how it is right there. There's a screw on the bottom of it. You'll see me adjust in the video, and basically a real good slit fit boss at the top, and then some set screws. Really kind of willy-nilly if you think about it, but it gets it done, right? So you just take your tool post off of it. You know, move your compound all the way forward, and lock it down, which you should be doing anyways if you're not, you know, when you're not using it. And then basically, you know, it's just got like a big ass T-nut, and then 2 Allen heads. It just bolts right down. Now depending on where, you know, you can see the pivot point right there where the handle's at, and depending on where that tool is in relation to that pivot point is depending on whether you're turning a concave or a convex radius. You know, if you needed to make a real big radius, you'd use one of those straight shank ones, you know, so you were coming directly off the pivot point. So you just set your tool height here, and like I said, there's a set screw that's underneath it. Well, not a set screw, but it's like a set screw, but it comes to a point, and the bottom of those centerpieces have a point in them, so it threads into the main body, and it rides on that point, and it'll just raise or lower it depending on where you got it set at. That's why I've got, if you look at the top collar, you can see that gap up there, right where my hand's at. And you'll see I adjust that. That's why I have that gap there right now, so I can get the height that I need. And on this, it's bottomed out, so I mean, I'd have to shim the thing up to get it any higher. And so now that we've got that at the right height, now we'll loosen everything up and drop the handle down into it. Now that collar that I'm working with right there, that's the graduations collar. You know, you can set your zero if you had to turn you know, a radius to a certain degree. You set your zero at the beginning or the end of it and work off the tick marks on that thing. I mean, I'm setting a zero, but it really doesn't matter at all for what I'm doing. And then I'm just filing the edge off, because that's the side that's going to go into the chuck, so you don't want any burrs. It's when you're working your chuck, right? Or the jaws, whatever. You know what the hell I mean. And to set that up, you can see the faces if you look. When we put the V-block up on there, you'll see the face as well. But basically from that face to the center of the pivot, you've got a 1/2 inch. So you're going to measure off that face to your tool tip, plus that 1/2 inch, and that'll let you know what radius you're actually turning. And then the reason why we're using this tool instead of the straight shank one. I mean, you could have used either one of them, I reckon. You just had to have probably a little more tool hanging out to clear that boss of the face of your work. Yeah, you measure off that face plus a ½ inch, and we'll do the same thing here. We'll come off that face with a 1, 2, 3 block on the side of the work there. You know, so we'll move it in a ½ inch plus the V block plus the radius of the work, and then that should bring the tool to the center of the work. Now, the first thing I'm going to do though is first thing I'm going to do here is drill it. We were going, if I remember right, we were going 1 1/4 inch deep, or 1 1/8 inch deep total. Might have been, yeah, 1 1/8 inch deep. Might have been 1 1/4. But so I basically just drilled just shy of that depth. You know, so the whole center was out of the way. You know, I probably could have used a bigger drill bit than I used, but it's a pain in the ass finding what you're looking for, so you just kind of grab the fastest, biggest tool you can find, and you're going to get wrapped up in searching for a fucking hour. And well, it only takes 30 minutes to do the whole radius, so why waste an hour looking for a tool, right? I mean, I could have turned the radius from this point right here and been faster than potentially faster than trying to find the maximum size drill bit that I could squeeze in there. You know, when we started, it wasn't supposed to do any turning on the outside or anything. He just wanted the freaking radius in the end of it. So after I turned and shut the camera off, I put the damn thing back in there. Well, I didn't take it out, but I went ahead and cleaned it up because I didn't, I don't like that crap. If somebody had a pile of freaking rust. Good thing about using a tool like this that most of the guys around there most of them never even heard of, let alone you, because everybody wants to be there. So I got a guy on the coolant bottle, teacher over there helping with the damn, making sure everything's staying under the chuck. Kind of peck drill almost. You really don't need to peck. All you got to do is stop turning, because as soon as you take the tool pressure off, it's going to pop a chip, right? So I just kind of turn in, stop, let the chip pop, and turn in, stop, let the chip pop. So you can see the little faces right there by the 1, 2, 3 block. Those are the faces you want to be coming off of when you're measuring. You know, like I said, you're going to go in, whatever you're using to measure. I'm using the V block because that V clears the tool, right? And you need those faces facing forward. So I'm moving over again, 1/2 inch plus the V block. I'm moving over 1/2 inch plus the V block, which I think was 2.5 inches, plus half the work, or the radius of the work. So we're just running it in. Yeah, you can see the little clearance back there in the back of the base of it for the, you know, your tool, if you got it sticking out. You know, if we were running that tool on a smaller radius, then especially if you had to get back into a hole or something like that. You know, so neat little tool, I reckon. Now I went past my mark right there, and always back up a lot further than you think you need to, and then come back into it to hit your number, because you got that backlash in the screw. So if you just try to back up and hit the number, you're gonna wind up screwing the pooch, right? You know, if you just back up to where, you know, if you, let's say you started at 30 and you just backed up to 30, you're not going to be at 30, buddy. You need to back up past that 30 and come back into it. Now I basically just touched it off the face, and since I was going to take, I was planning on taking 50,000s off the face, I just touched off the face, moved in 50, and then that's where we're going to start the radius at. You know, that way when we take the 50, you know, it's already accounting for the 50 cal that we're taking off. Although for what we're doing, it wouldn't matter. For this, you could almost just get kind of willy-nilly with it. You know, it's just a dude to blow glass balls, I guess. And I guess they had the glass on the end of that pipe, and they'll set it down in there and blow and turn at the same time. And it just, I don't know if it's going to take the shape of that radius, or if it's or if they just want a radius, you know, for it to roll in. They can do multiple sizes off of it. I'm not sure how it works. I don't ask all them questions. I just do what you tell me to do. You know, I'll give y'all a little clip of it actually turning when you're ready to go into that 4 times fast forward, just to get it just to get past the monotony of the same thing over and over again. There goes my spray bottle guy. Who needs a coolant mister, right? You don't need no coolant mister. You got John or whoever it was that was working on a bottle. You know, you gotta figure that this tool right here is essentially like a threading tool, right? I mean, it's ground to a point. So we're moving at a pretty good clip. When we come back out of the slow motion, I'll give you I'll give you a comparison of what I'm talking about for the clip. It's kind of hard to tell right now because we're moving so much faster than we actually are with the high speed, or with the fast forward, whatever you call it. Again, y'all know what the hell I'm talking about. I don't know, we're probably taking, 20, 25 at a pass. I mean, you can't take a whole lot. The damn thing starts squealing like a pig. But again, it took 30 minutes for me to actually put that in there, before cutting everything out, not counting, setup and all that stuff, but the actual machining, you're only talking about 30 minutes. And a lot of that 30 minutes was bolting things down and stuff like that. I edited it out, I didn't get it on video when we were actually setting the tool length and everything. So that whole portion of the video was just chopped off because we didn't do it on the lathe, we did it on the surface plate. Monotonous, huh? I'm getting it done though. Buddy got his frickin' ball, whatever the hell, ball fixture maybe. I don't know. I don't know if you call it a mold. I guess maybe it could be a mold. We're getting closer to it. We're getting ready to come out to high speed. Or fast forward rather. So now if you think of that in terms of your lathe carriage, advancing the tool, even at that speed right there, you're moving at a pretty good freaking clip, right? I mean, that's hauling ass. And of course, when I get right down to it though, you'll see on that last pass, I slow way down. I feed in slow and then I feed out even slower with a spring pass. And each one of these passes, I feed in and then feed out on the same depth. So it's kind of like I'm doing a spring pass on every retract, I guess. Especially with such a sharp tool, because it'll, you move too fast, and so you're leaving a thread in it. Is what it winds up looking like. Surprisingly decent radius there though, or finish rather. But as you can see, it really isn't rocket science, right? You just set your freaking tool, touch off the side, move in, and start turning. Just move the damn handle, and it makes a radius. And it's all in the map and the setup before you ever start cutting. And then of course getting to depth. But again on this, I mean, there's nothing scientific about it. If if I had to go deeper than I needed to go, I could just face the top of it off. It wouldn't matter, you know. I mean, it's just a chunk of rusty metal is all the dude wanted. So there was no need to overcomplicate a fairly simple process. I notice it's kind of monotonous just watching that tool go back and forth. But y'all boys just gonna have to watch it if you want to watch it. That's all I can. It is what it is, man. Nobody don't have experience using one of these. This might be the video you need to look at before you gotta put a radius in something. And the same principles apply to pretty much any Radii Turner, whether you're doing one of the Steve Badair types or, you know, that was one of the first things I actually machined when I started machining, was one of those kind. Never used it. We just made it because it was cool. But which I don't do too much of that anymore. I don't make things just to make them. I make things because I need it or want to make it, you know, for this or that. But it ain't just for the sake of doing it. And we turn that light on because we're getting close to the bottom of that hole, and I'm trying to see that drill point. You know, every pass it just gets smaller and smaller and smaller in there. You know, and then when it gets real small, if you're not paying attention, it's gonna look like you cleaned it all up, and you'll have a concave radius to your concave radius. See how slow I'm going right there. This isn't, slow, even on the outfeed. Because again, you know, it's going to want to leave like a thread to it, right? So you just, you got to come back across it and go slow as well. Make sure that you're getting that old thread out of there. It's not actually threading, but y'all get it. Swirl, bad finish, whatever the hell you want to call it. And I also put two hands on it. One of them kind of counterweights. I do the same thing when I'm trying to bump into something on the handle, on the lathe or mill or whatever. Two hands acting as a counterweight is always better than no hand. So if you're ever going to go into a little slow motion, let you see it best as I could, you know, with the way I took the video, I guess. But and then I should give you a picture of the, you know, again, we weren't supposed to do nothing but put that radius inside of it, but you know, after the video was off, I just had to turn the outside, face it, flip it over, face the back, and just make it clean. And that's it.